Hi guys, let's go ahead and talk about combinations and compositions. Oops. And basically what all these mean is just different operations that we can do with functions. So we can do the same operations for functions that we can with numbers. So we can add them, and I know that this seems simple, but when it says f plus g of x, that's how we read this first one right here, f plus g of x. That just means add the functions together. So we can rewrite this as f of x plus g of x. So we take the first function and we add it to the second function. Simple as that. Same thing when it says f minus g of x. All we do is f of x minus g of x. F times g of x, that's just going to be f of x times g of x. F over g of x is just f of x over g of x, where g of x cannot equal 0 because we know that we can't have 0 in the denominator. And then this last one is a little bit tricky right here. We read that as f of g of x. So that little open circle means of, not times. And you can rewrite that as f parentheses g of x. So what that means is plug g into f. So we'll go ahead and we'll see an example of that down below. But that one you're going to actually replace x with another function, f of g of x. All right, so let's go ahead and try a few examples. We want to find f plus g of x, then evaluate it for when x equals 3. So f plus g of x is going to be x squared plus 2x minus 1 plus 3x minus 1. Now, we don't have anything to distribute because that's just a plus sign. So this is just x squared plus 2x minus 1 plus 3x minus 1. Then we can combine our like terms. So that's going to be x squared plus 5x because we have 2x and 3x. And then minus 1, which is going to be negative 2. So that is what our function equals, f plus g of x. And then we want to evaluate it for when x is 3. So f plus g of 3 is going to be 3 squared plus 5 times 3 minus 2. So 9 plus 15 is 24. 24 minus 2 is 22. All right. Now let's go ahead and do g minus h of x. So we're going to do g of x, 3x minus 1, minus h of x, which is square root of x plus 7. And then if we see here, I can distribute that negative, but not through the square root. The only thing I can do is just put it on the outside like this, minus square root of x plus 7. We cannot distribute through a square root. We can only distribute through parentheses. So this is as simple as the function gets, 3x minus 1 minus the square root of x plus 7, because I can't combine any more like terms there. Now, if we want to evaluate that for when x equals negative 1, we're going to have 3 times negative 1. Oh, let me go ahead and write it a little more clearly. We're going to have, g minus h of negative 1 equals 3 times negative 1 minus 1 minus the square root of negative 1 plus 7. So then that's going to give us negative 3 minus 1 minus the square root of 6, which would be negative 4 minus the square root of 6. And that's as simple as that gets. You can type that into your calculator if you want a decimal approximation, but if we want to leave the answer exact, then we would have to leave it like this. Again, because I can't combine something under a square root with something that's not under a square root. Alrighty, now f times g of x, so then we're going to have x squared, plus 2x minus 1 times g, which would be 3x minus 1. So here we have a trinomial, a quadratic, times a binomial, and we just need to FOIL this. But FOIL is a little bit weird when it's 3 terms times 2 terms. We're going to take every term here times every term there. So I'm going to do x squared times both, then 2x times both, and then negative 1 times both. So that's going to be 3x cubed minus x squared plus 6x squared minus 2x minus 3x plus 1. So I took x squared times both, 2x times both, and then negative 1 times both. Now I can combine my like terms. That's going to be 3x cubed plus 5x squared minus 5x plus 1. So that's our function there. And then we can go ahead and evaluate it for when x equals 4. So f times g of 4 is going to be 3 times 4 cubed plus 5 times 4 squared minus 5 times 4 plus 1. So then this is going to give us 4 cubed is 64. 64 times 3 is 192 plus 4 squared is 16. 16 times 5 is 80 minus 20 plus 1. So then that's going to be 192 plus 80 minus 20 plus 1 is 255. And you can just type that into your calculator. That's what I did. Alrighty. Now f over h of x. So then we're going to have x squared plus 2x minus 1 over h, which is square root of x plus 7. And this is as simplified as this function gets as well. Because again, I have 2 things under the square root, 3 things not under the square root, and I can't combine any of those like terms. So that's as simple as that function gets. If I want to evaluate it for when x equals 2, I can go ahead and just plug 2 in. So f over h of 2, 2 squared plus 2 times 2 minus 1 over the square root of 2 plus 7. So that's going to equal 4 plus 4, which is 8, minus 1, which is 7, over the square root of 9. We know the square root of 9 is 3, so this equals 7/3. Real quick, I want to go ahead and talk about the domain of this function. The domain of the function is going to be a little bit different because notice we have a square root in the denominator. So I know the I know that the square root of x plus 7 can't equal 0. And then that means that x plus 7 can't equal 0 because the square root of 0 is still just 0. So then x cannot equal negative 7. So that has a restricted domain there. Here, our x equals 2. That's what we plugged in, and so that's fine. That is in the domain, we can see. Alrighty. Last one, let's go ahead and talk about composition. So g of f of x and h of g of x, and then evaluate the second one for when x equals negative 2. So we're going to write g of f of x, g of f of x, I'm going to write it like that. And that means that I'm going to take g of f of x is x squared plus 2x minus 1. So just like we would if it said g of 3, we would plug 3 in everywhere there's an x. In this case, we're going to plug a whole function in anywhere there's an x. So we're going to go to our function g, which is 3, and then there's an x. So I'm going to plug the whole function in for that x. Now x is not just x, but it's a brand new function. So I have 3 times that minus 1 still, because g of x is 3x minus 1. So then I distribute 3x squared plus 6x minus 3, and then I still have the minus 1 outside. So it's going to be 3x squared plus 6x minus 4. So that's what g of f of x is. Now, h of g of x is the same idea. We're going to go ahead and plug in g into h. So this is going to be h of g of x. So that means h of 3x minus 1. So I'm going to plug that function into h of x, which is going to be the square root of 3x minus 1 plus 7. Again, I'm going to take this function and plug it in for x. Then when I do that, I'm going to have the square root of 3x minus 1 plus 7, which equals the square root of 3x plus 6. And then it says evaluate that for when x equals negative 2. So this is going to be the square root of 3 times negative 2 plus 6. Sorry, this is h of g of negative 2. So that's going to be 3 times negative 2 plus 6, and that's going to equal the square root of negative 6 plus 6, which is the square root of 0, and we know the square root of 0 is 0. All right, we'll keep getting more practice with this in class.